So yeah, welcome everybody. Really glad that you could come to this session where we get to present the results of the EMBARK report that Builders for Climate Action and Passive Buildings Canada did with generous funding from the Atmospheric Fund. And the EMBARK report stands for Emissions of Materials Benchmark Assessment for Residential Construction. We were stretching to find a good acronym. And it's a study of the material emissions of residential buildings in the GTHA with the idea of, how do we try to get those emissions from where they are now, which is about 1 million tons a year, down to zero. And before I dive in, I just really want to thank and acknowledge the team that made this study possible. Nobody had ever done a study like this before. There are embodied carbon studies of individual homes, but nobody's looked at a set of 500 homes, and all according to the same methodology. And so without this incredible team of researchers and supporters and data people and everything, it wouldn't be possible. So I just really want to thank them. I get to stand up here and talk, but this wouldn't be possible without them. So framing the problem is, I think, pretty easy. Everybody knows that if we're going to try to keep things to no more than 1.5 degrees Celsius of warming, we have to get emissions down pretty quickly by 2030 to sort of like 50 to 65% of what they are now. And so that's everything. And because I'm a builder, you're probably builders, what we're thinking about is homes and how do we get there with houses. And just to sort of frame the challenge that's in front of us, both the Canadian government and here in Toronto, the Toronto government have targets for reductions, which for Canada by 2030 is 40 to 45% less, and net zero by 2050. And then Toronto has a specific 50% less in the building sector by 2030, and then like the Canadian government down to net zero by 2050. They're great targets, and it's exciting to sort of be part of the movement to see if we can actually meet them. So currently when we think about those targets, so when Toronto or the federal government says we want to cut building emissions by 50% or get them down to net zero, they're really only talking about operational carbon emissions. So the energy a building uses, and then whatever's supplying that energy, the emissions associated with it, that's kind of what's been taking all the focus. And so what we've been looking at Builders for Climate Action is what we call material carbon emissions. And those are the emissions associated with extracting, transporting, and manufacturing building materials. And a pretty good percentage of what the full emissions profile of a building material happens in that upfront phase. If you're kind of in the embodied carbon world, you'll hear that term upfront embodied carbon, and that's what we're sort of talking about, the stuff before anybody moves into the building. What did it take to just make the materials that go into the building? So, our look at this now, obviously I'm going to just talk about the embodied carbon bit, but I think in the buildings world what we need to do is think about these things as both. It's not an either or, they're not in competition with each other. You don't have to give one up to pay attention to the other. Both of them need to get to zero by 2050, or we don't get the prize of a reasonable climate. And the analogy that I like to use for ignoring those material emissions is like if we wanted to think about the emissions from our food system, if we just looked at, well, what does it take to put my food in my refrigerator and cook it? I'd go, well, there's my emissions from my food. And it's, not thinking about materials is like not thinking about the whole food production system. There's this whole other side, and just like with food, that other side is actually bigger than the side that we sort of pay attention to in the home. So when I first started doing this, I was thinking about it on the scale of one building. I was literally just trying to back of the envelope figure out, hey, this house we're doing, I wonder what the material emissions from this building are. And I got numbers, and the numbers seem big, but what was interesting to me is, well, what happens if we look at this at scale, from more than just one house? And so the EMBARK study gave us a chance to really do that. Before we did the EMBARK study, we did a study for Natural Resources Canada in 2021, where they gave us 190 model homes from across the country at like a whole range of different energy efficiency levels, using a whole bunch of different fuels in different cities across the country. And so we got a real range of embodied carbon results, but the sort of the average across those 190 homes was this 150 kilograms of emissions per square meter of heated floor area. And if we then take that and multiply it by the number of square meters of that kind of housing stock that gets built every year, we get this 8.5 million tons of emissions per year just from low-rise residential building materials. So it's, I think, a much bigger problem. I think when we handed the report over to Enercan, you could hear jaws kind of hitting the floor when they saw this. I don't think anybody was expecting to see results at that scale. And so, you know, it's really great to be able to start to understand the full impact of this issue nationwide. Part of that Enercan study involved putting different material palettes to those buildings. So we kind of had a set of plans that Enercan considers their kind of like, you know, residential house standards across Canada. And so, you know, we applied different sets of materials to all those different plans. And what we saw was if we just took those houses and picked all the materials that are currently available and affordable and code compliant from, you know, retailers and big box stores, and put them all into one house, we could actually get that house from that 150 kilograms per square meter average down to 2. So essentially a more or less a zero carbon house. And that would take, if we did that across the country, that would take that, you know, 8+ million tons of emissions and drop it down to a 250,000 tons. So, you know, this vast change. I think that actually would be at the same level as when Ontario shut all its coal-fired power plants down, which is the single biggest emission drop in North America. That's achievable, you know, on the scale of residential buildings in Canada. And then the second model that we did to look at sort of future scenario was applying what we called the best possible materials. And the reason we applied that set of materials is because it represents the kind of construction that I've been doing my whole career, which is using a lot of bio-based materials, agricultural residues, straw, hemp, wood, cellulose, things like that, in as many places as they're practical to put into a house. And because those materials took CO2 out of the atmosphere when they grew, and then typically release it back to the atmosphere, when we take that material that's drawn that CO2 out of the atmosphere and lock it up in a building, which is a pretty long-term safe place to put it, it's actually like carbon storage. It's sort of a net negative emission. And so we can actually, you know, make buildings that they still have materials with emissions, but they have all this storage. And if you use enough of those materials, the whole building ends up in the territory of net storage, and sometimes pretty heavily so. Minus 50 kilograms per square meter was the best result from the Enercan study. We built a building for the Teachers Union in Lindsay, Ontario, that has 160 kilograms of storage per square meter. So, you know, that kind of result is possible, and something that, you know, when we're struggling with climate change, we tend to struggle with, like, how are we going to get 5%, 10%, you know, 30% reductions? And then what we're sort of talking about here is, well, how do we flip the paradigm around completely? Now there are no emissions, and we're actually not just not making the climate worse, we're actually making the climate potentially better by making these carbon storing buildings. So we knew that going into this EMBARK study. We'd done that study for Enercan, but for the EMBARK study, we actually decided we needed to build a really robust, resilient, and easy to use tool, which we called BEAM, and that was used to run all of these plan sets through we ran all the plan sets through BEAM, and what we focused on were these upfront carbon emissions, like I said before, the sort of harvesting, transporting, and manufacturing of materials. That's what we were counting, and we counted those because they are the majority of the emissions from building materials over their entire life cycle. It all happens up front, and because it happens up front, these are the emissions that we need to fix today. There are end-of-life emissions and things like that, but with building materials, they're pretty far down the path, and if what we have to do in 50 years is figure out what to do with those, that'll be a pretty sweet place for us to arrive at. So, right now our focus is on these upfront emissions. So BEAM focuses on the structural, enclosure, and partition materials. We sort of picked those. I think they kind of picked themselves, partly because that's the bulk of the material, like in terms of mass in the building. It's the majority of the stuff that goes into a building. But also from a data point of view, this is the stuff that right now we actually have good data on. So there are enough environmental product declarations in these material categories that we can count everything that falls into the structure, enclosure, and partitions. But what we can't count, because the data doesn't really exist, is any of the mechanical gear. There really aren't any environmental product declarations on plumbing, electrical, HVAC equipment. There's very little on things like millwork, stairs, appliances in particular. So all of that is not included. So when I'm giving you the numbers and the results for EMBARK, just sort of keep in mind that we're really capturing sort of somewhere between 50 to 60% of all of these material emissions in a building, because they're the only ones we can count right now that we have the numbers to count. And so what we really wanted EMBARK to do was reflect like real as-built homes, because we'd done this study for NRCan, which was, they have model plans, and then we put model sets of materials to those plans, which was great for sort of understanding, the parameters of the topic. But what we really wanted for EMBARK was, how are people building houses right now, with exactly those materials? So we put a call out to developers in the region. 8 developers responded with plans. They gave us a total of 59 different sets of plans. Many of those were built sort of multiple times, the same house over and over. We were mostly going for sort of production builder, tract builder kind of homes, because that's mostly what gets built. So we had these 59 house plan sets, which totaled 503 as-built homes, all built within the last 2 years. So it was a really good sample of what's going on, and at a large enough scale that it sort of feels like it's pretty representative of what's going on. And so the kind of the top level results of all of this is that the worst home in the study had 561 kilograms of emissions per square meter of heated floor area. So over half a ton. That was a real jaw-dropping thing to see. The study that we did with NRCan sort of predicted that if you kind of put all the worst materials together, you could end up over 500, and then it was like, oh yeah, people do that. It's not just a pretend model that we made. It's a set of materials that some builders actually do build with. So that was at the high end. The average across the set of plans was 191 kilograms of emissions per square meter, and the best result was 116. So that was kind of the range, the high end, the low end, and the moderate bit in the middle. And at that average, and for the number of square meters that gets built in the GTHA, that means from the emissions we're counting, there's about 840,000 tons of emissions per year from GTHA homes. So we build about 17,000 single family homes, duplexes, and row houses in the GTHA in a year. So we kind of took all the municipal data about how much square meters gets built of all the different kinds of plans we had, and so that was the average across that set. And like I said, there's a lot of materials that aren't being counted. All the mechanical stuff and the appliances and things like that. Our estimates of what those are, kind of just going from how much raw material, like how much ABS plastic is in plumbing pipes, how much copper is in a heat pump, all of those sorts of things, gave us the sense that we're pretty much counting about half the emissions. So, if we were able to count everything, our assumption is that in the GTHA, the homes are actually responsible for about 1.5 million tons or a little bit more. So it's bigger than I thought for sure, and bigger than most people think. So across the country, the results up there from EMBARK, that's the ones I just showed you. I talked about the study with Natural Resources Canada, that's the set of results in the middle. At the same time, or just a bit actually before we did EMBARK, we did a smaller study for Nelson, BC, where we did 34 as-built homes in that region. And what's interesting is they kind of mapped relatively closely, especially in the average. Like our model average for Enercan and our actual average for Nelson was identical, and just a little bit lower than the average for the GTHA. So this is kind of what the sort of best, worst, and average results looked like across those three studies, which both gives us a sense that things are a bit different in different parts of the country, but also that we have a pretty good sense that the average, there is kind of an average in the country, and it's sort of somewhere between 150 and 200 kilograms per square meter. And what we also learned from the EMBARK study, and this was mirrored really closely in the Nelson study, is that essentially 3 material categories are 70% of those emissions. And those would be concrete, insulation, and cladding. And the numbers were almost identical between the percentages between the Nelson study and the Toronto region study. And so, that gives us a pretty clear sense of, well, if we're going to tackle this, we know exactly where we need to tackle it. There's no point sweating your roofing. It's 2% of the building typically, and so we're not going to make our big wins in roofing and framing, in any of the structural posts and beams. Windows is a little bit bigger, but we can't do much about that. Like, glass is glass, and so until somebody invents a low carbon way of making glass, that's going to kind of stay. So if we really concentrate on those big categories, that's where we're going to really drive change. So as part of the EMBARK study, we took not the worst emitting home, because it was way higher than average. We took the next highest home, which was 262 kilograms of emissions per square meter, and we thought, well, what could that builder have done to sort of do better? And so we went through some stages of essentially material replacement, and the first step was the little green bar. That first reduction was, what's the best concrete mix, the lowest carbon concrete mix we can get in the GTHA right now, and what's the carbon footprint of that, and let's substitute that. So we had a little bit of a win from changing the concrete. This big bar, the second bar, is what if we change the attic and the wall insulation from whatever it had been to cellulose. And because cellulose is one of those carbon storing materials, it doesn't just lower the emissions, it sort of like makes them negative. So you get essentially a really big win from doing that. The next bar over is changing the foam, the continuous foam insulation on the outside of the building to a wood fiberboard insulation. And again, that's sort of one of those carbon storing materials, so it has a relatively big impact. The next bar is changing brick cladding. Brick is about almost like 10 times higher emissions than pretty much any other residential kind of cladding. So if you change from brick to just about anything else, you get that next little win. And then the final bar is taking things like flooring products, drywall, I think pretty much just those two, and just looking at all the environmental product declarations and going, well, what's the lowest carbon drywall? Like, what manufacturer has the lowest carbon footprint, and just switching out for the kind of like the best available material. And those changes brought that house from 262 kilograms per square meter down to 66. So that's a 75% reduction in the one of the higher emitting homes in the GTHA. And we didn't do a full cost analysis of what those changes would actually cost, but my builder instincts tell me that the 75% reduction home is no more expensive. It might actually be less, partly because a lot of the XPS foam and the brick that we replaced are the most expensive insulations and or most expensive materials in their category. And so for something around cost neutral, we can see a pretty big reduction, a 75% reduction in this one home. And then we also took the best performing home in the study and put the same substitutions to it. So it was already starting a lot lower. Instead of 81 tons of emissions, it only started at 33 tons, but we put all the same materials to it. But what was interesting is it ends up in almost the exact same place as the really bad home. So what that told us was it didn't matter really the design of the home, the style of the home, the size of the home. If you kind of like put a certain material palette to a home, you get something close. The other one had I think 66 kilograms per square meter, and this one ended up at 56. But they kind of, if you use this material palette, they kind of all end up in that range. So this one had just over a 50% reduction, but it was starting from a lot lower and ended up only slightly better than the comparison house. And this substitution exercise was the best part of the whole study. I got to say, running lots and lots of plans through a calculator tool is not exciting, but when you see what pops out the other end, that is exciting. And it was exciting to do these substitutions because we realized, oh, Toronto has this 50% reduction target for buildings, and we just showed that you can do that, not in 8 years like today. If builders in the region sort of took that seriously, looked at that set of materials and went, yep, I can do that, then there we go. We've met Toronto's 2030 buildings target with both houses, the one that started off better or the one that was really high emitting. They're both at least 50% reduction, and so that's what the city's aiming for, and so there's the roadmap to being able to do that. The other thing that was exciting to look at was, seeing that there was a tract builder in the GTHA whose sort of suite of homes came in at this 116 kilograms of emissions. It's not the lowest number in the world, but it's 40% lower than the average. And this is not a low carbon builder. This is not somebody who is like, I'm going to set out to see if I can beat what's going on now by 40%. This is their affordable, business as usual, I'm just making homes to make a living. The way they do that is 40% better than the average. And so, what that tells me is, like, this is doable. It's doable right now because there's somebody out there running a company, building, a couple hundred homes a year at that level of emissions. And so if we want to get to 50% reduction in the GTHA, there's a builder who's already at 40. That's a pretty good start, and they know how to do that. They've got the materials down. They know it's affordable. They know it's meeting code. All of that kind of those questions that often come up about this. At least to get down to the 116 range, that's entirely doable. If all the homes in the GTHA went from that average down to that thing that somebody's already doing, that's over 500,000 tons of emission reductions per year. So that's on the table right now. If we could all do what that builder is doing, which is nothing special, let me tell you. It's not, they're making homes that look like everybody else's homes. There was no real conscious effort to make a low carbon home. But even if all the builders could get to that level, 500,000 tons of emissions a year is no small reduction to be able to make almost instantly if we wanted to. And then, being the straw bale builder that I am, I wanted to push into that territory. So, we did these, affordable code compliant reductions and found that 75% reduction. And then we sort of went one step further and thought, well, what if we insulate the basement with hempcrete and we put straw on the walls and we, do some other things like that. And, we ended up in carbon storing territory, minus 47 kilograms of emissions per square meter. And if we could do all the GTHA homes that way, that 800-some thousand tons of emissions that are happening would disappear, and we'd be, putting away 2,250 tons of emissions per year. So this is a little bit more far-fetched, but I've been building homes that do that for the last 25 years. All the questions about, will they last, do they burn, all that kind of stuff. They've been doing fine for a quarter of a century. I think we really can see that there is a pathway to being able to do that more broadly. And I know that the question or the issue of cost always comes up. It wasn't in our scope for the EMBARK study to really delve into that, but for the NRCan study, they wanted us to look at material costs, so separate from labor, which is then can be a little bit misleading. But what was really interesting was we found absolutely no correlation between material cost and emissions. Sometimes the highest emitting material was also the most expensive. Sometimes the lowest was the cheapest. Sometimes the lowest was the most expensive. Like, they could fall anywhere in that range. It was the amount of emissions associated with the material did not predict its price. And so, I think what that says is that, you can be very strategic about it. You can figure out, like, dollar per dollar, where are the wins in terms of reducing the carbon footprint, and where are the things that currently you just can't go there because you can't bear that cost. But I think it's really possible to, the interesting ones here are in the middle range, where the price of those two wall systems was almost identical, but the emissions in this one are actually getting into the negative territory just for the wall system for exactly the same price. So I think I would love to do the cost study in more detail, but I really don't think that we necessarily have to be spending a lot more money to reduce the emissions of the buildings. So I know, being a builder and talking with builders a lot, that change is bad. It was my 2-year-old used to say that to me, change is bad, change is bad. And I feel like 2-year-olds and builders kind of have that same attitude. And so, my suggestion isn't that, every builder in the GTHA start making straw bale homes tomorrow, because I know that's not going to happen. But I can see that because we already know somebody is at that 116, it shouldn't be too hard for everybody who's in the average, range to just start thinking about a 10% reduction per year for the next 5 years. That gets everybody from here to that nice, 40% reduction in a reasonable amount of time, affordably, in a controlled manner, and is sort of consistent with the national and the local goals for emission reductions. And then just keep going down that path. If you think about 10% a year, it's not a big step to have to take, and especially once you've started making those steps, you don't have to change 30 materials on your next house. You can change 2 and do that for a year. Get comfortable with it, get that into your flow, figure it out how to do it well, and then change the next 2, and then change the next 2, and there's enough low-hanging fruit right now that transition over the next 10 years is, I think, highly doable. And then there's more to do to get to zero on embodied carbon, and even more to do to get into net carbon storage territory. But it's not beyond us to be able to do that. And we're talking, you don't even have to start thinking about this for the next 10 years. You might want to start thinking about it now. Like, start making that plan. Like, what are the materials that are going to get me from here to here? A lot of them, you'd be surprised that you might already be using some of them. So it's if you think about it as a sort of like 10-year plan or 20-year plan, I think it's not that outrageous to think about changing our homes from this kind of like leading source of emissions into basically carbon banks, and putting a whole bunch of carbon away and making the climate better as we build homes, instead of incrementally making it just a little less worse. So the EMBARK study ends with a few key points. The first one being just encouraging everybody in the home building sector to just start thinking about measuring these emissions. So our beam tool is now available for free. So there's a really quick and easy tool for doing that. We also helped NRCan make it's kind of like a sister tool that they call MCE squared. Both of those work from the same data set. So there's free tools to help you measure it. It's amazing when you start measuring. I've been doing work for developers now. As soon as you see the numbers, you start having those aha moments of like, oh, that, like I could change that. And the tool is really great because it puts, all of the results for all of the materials right in front of you. So if you're looking at insulation, if you're looking at cladding, you've put all the dimensions of your building in, you see the results for every potential cladding material that's on the market. You see the results for all the insulation. So you get this really great, side-by-side comparison. So I think measuring is really important. Demanding transparency. So I've mentioned that in some material categories and for some manufacturers, we don't have the environmental product declarations that gives us that data. So we all need to ask them for it. If you can't find it, if it's not, say, in BEAM or it's not an MCE squared, bug the manufacturer. We've got a template letter on the Builders for Climate Action website, like write to them and say, I'm not going to buy your product anymore until there's an EPD. And it's surprising they start to want to produce those. So that's really important because the more materials that are in there, the better resolution we have, the easier it is to kind of understand what you can change and what you can switch to. And then, like I said, do the 5-year plan thing. Once you've started putting your buildings into a tool like that, once you've started seeing what the changes are, it can be a very sort of calculated, stepped approach to think about, what are the substitutions. All of these studies looked at straight up material substitutions. There are also design changes and substitutions you can make. When you look at 35-ish% of all the emissions from a home being in the concrete. Imagine if you just don't put the house in the ground. If you could make a concrete less house or just a house with less concrete, a third of your emissions could go away like that. And that's that's not a material substitution. That's a design strategy that you can undertake. And then also, this isn't, I think, a sort of one trick, way of looking at things. I got into thinking about embodied carbon because in our building practice, we were trying to come up with metrics for everything, metrics for energy, metrics for building toxins, metrics for, and then I was like, oh, embodied carbon, you find the metric for that too. So, one thing that I have really noticed is that, this is a deep dive into embodied carbon, but there are all kinds of stacked benefits to the materials that do well in the embodied carbon scale, in that they are almost always either way less toxic or completely free of toxins. They also tend to be more locally manufactured. Quite often they're more affordable. They come from supply chains that are closer regionally and support different aspects of our community, especially a lot of the agricultural residues. We can either pay farmers for their waste to put into buildings, or we can pay oil companies for their stuff to put into buildings. There's sort of great reinforcing aspects to local economy and local supply chains if we start thinking about this too. So it's, it turns out that it's not just, oh, you get great embodied carbon numbers. You actually get sort of healthier, more resilient buildings and healthier, more resilient communities from going down those paths. So that's kind of the high-level summary. I would encourage you to go either to the Builders for Climate Action website or the Passive Buildings Canada website and download the report. It goes into a lot more depth. It goes into all the material categories and shows you a breakdown of how we made all those substitutions, and there's a lot more depth to the actual report than I could cover here. So that's available for free from either of those websites. And I really want to thank you for your time to come and listen to this. And I would be glad at this point to take any questions that people have.